Tell you a little bit about our next speaker, who is Dr. Milton Mills. Dr. Mills is an internist at Fairfax Hospital in Virginia. He was educated at the Stanford Medical School. He became interested in the relationship between diet and health at a very young age, and as a teenager became vegetarian. He's very active in the Seventh-day Adventist Church, which is an extremely vegetarian-friendly religion, I believe. Dr. Mills is incredibly warm, genuine, funny, loving. He's a terrific guy, much like all the rest of the speakers who we have up here during this weekend. Dr. Milton Mills, come on up, please.
Well, everything that we've heard this week begs the question, why? We've heard that, for women's health, for heart health, to reduce cancer risk, to treat obesity, we all should be eating a plant-based diet. Now, is that some sort of happy accident or some weird coincidence that, here we are, creatures who are, if we believe what we're told in school, we're supposed to be omnivores, and somehow switching to a plant-based diet is going to have all these benefits? And why should that be? That, to me, that just absolutely does not make any sense. Because if you fed your dog or your cat a purely plant-based diet, and particularly a high-fiber diet, they would get sick and eventually die. But we actually stop getting sick and get well, and in fact, do much better. Now, you contrast that with the fact that if you fed a high-fiber plant-based diet to a horse or a cow, they would flourish. So again, the question is, why? Why is it that this diet is better for us? Could it be that we are actually not designed to eat animal foods? And I'm going to jump ahead and tell you that the answer is yes, but obviously I have to prove my point, and that's what this lecture is all about. Well, how are we going to do that? How am I going to prove to you that we are not designed to eat animal foods? Well, let's look at animal foods and let's look at plant foods. Now, a high-protein animal food is obviously animal flesh. High-protein plant foods are things like oats, broccoli, beans. What's interesting is that if I sat a little pile of oats, beans, and broccoli next to a piece of meat, we all would recognize that they look very, very different. They're very different in consistency. They're very different in what they're made up of. And what that tells you is that animals that are designed to digest those different types of food need very different kinds of digestive mechanics. So what we're going to look at today is we're going to look at how animals that are designed to eat plants, animals that are designed to eat meat, and ourselves, humans. And we're going to compare the groups to see where we fall on the spectrum. Now, there's another interesting point that I want you guys to be thinking about while I'm talking, and that is the fact that, as you all have heard, all plant foods contain fiber, and the fibrous portion of plant foods is the cellulose portion. What's interesting is that cellulose and starch are made up of exactly the same material, sugar molecules. The only difference is in how they're bonded to one another. The cellulose is bonded the sugar molecules are bonded in such a way that one, doesn't dissolve in water, and two, mammals don't have the enzymes to digest it. So if you're an animal who's designed to eat, say beans or oats, and you know that part of what's in there is stuff that you can kind of digest and absorb, but then you're left with all this leftover fiber, what do you do with it? Do you just chuck it out the window because it's, no good? Well, or do you find some way to extract some of the, at least part of that energy from that cellulose? So just think about that too. Let's see. What other little notes do I have before I get started? Okay. Let's see. All right. So let's get started. So the title of our talk today is, Are Humans Designed to Eat Meat? Can everybody see that? Can we take the lights down just a tad so that the colors come out a little bit better? This is part one of the talk, and I start all my talks off with a quote from the Bible. This is from the book of Daniel. Give us vegetables to eat, water to drink. That's Daniel chapter 1, verse 12. Well, let's start off by talking about body plans. When you look at feeding strategies and energy efficiency, what you notice, first of all, is that carnivores are designed or optimized for predation. That is, they are designed to chase things down and kill it so that they can eat it. Because you see, when a wolf gets ready to have dinner, it has a very different problem from when an antelope gets ready to have dinner. When the wolf gets ready to have dinner, it's trying to eat something that doesn't want to be eaten. And it's trying to eat something that has legs and that typically tends to run away. You know, it's like, get away from me, wolf. Whereas the antelope, the stuff that it eats is rooted to the ground, so it doesn't tend to go anywhere, so it doesn't have to chase its food. So as a result, carnivores, like wolves, are optimized for predation, for chasing things down, killing it without being severely injured so that they can live and eat another day. But herbivores, like the antelope, are optimized for foraging because whereas their food, which are plants, are anchored to the ground, they tend to be spread out all over the place. So as a result, they've got to cover a lot of area to find enough food to give them the energy they need to live, eat, and raise their young. So they are optimized for efficiently covering large amounts of territory at a minimal energy expenditure. All animals have to procure their diets in an energy-efficient fashion because obviously, if you expend more energy looking for your food than you get from your food, you ultimately will not be around for a very long time. So as a result, carnivores seek weak, diseased, or defective, that is, stupid animals, because they are easier to catch. So you see, when your wolf goes out or your lion goes out on the savannah looking for something to eat, they don't look for the biggest, baddest antelope on the block. They look for the one that's limping or lame or old or, sitting around going do-do-do. Everybody else is running and the stupid ones are still eating like, hey, I got more food for myself. And as a result, they end up weeding out the sick, diseased, old, and lame, which is very beneficial for the gene pool of the antelope because they don't really need those kind of stupid people. I was working in the emergency room one night, and we had a guy who came in because, and I'm telling you, this was like about 11:30 at night, and it was during the wintertime when the days were short. He had fallen off his roof. You want to know why? Because he was up there fixing the roof and drinking beer. And I said to the ER doc, I'm like, wait a minute now, before we rush in there and fix this guy, do we really want those genes in the pool? I mean, if this guy didn't have enough sense not to try and fix his roof in the middle of the night and drink beer, do we really need those kind of genes hanging around? But anyway, herbivores, by contrast, they look for plant foods that are lush, verdant, beautiful, because those plants are what? The most nutritious. So they don't want the old scraggly, burned up, dried out grass. They want the grass or the leaves that are fresh and lush and verdant because those are the ones that are going to contain the most nutrients. So in a sense, they look for the most beautiful plants because those are the ones with the best nutrition. Well, what's interesting about that is that if you are a predator who uses an herbivore mentality, that is, instead of going out looking for the weak, diseased, and lame, you go out looking for the stuff that's the biggest, the brightest, and the best, you actually end up destroying the species that you're preying on. Think about that. Because what do we look for? Do we look for things that are diseased and sick and full of cancer? No, we want the buck that has, 15 prongs on his antlers. We want the biggest thing that's in nature. And as a result, we end up driving species towards extinction. But that's because we are using an herbivore mentality. Well, when you look at your typical carnivore, like my friend the wolf here, first thing you notice is that they are as what I call torpedo shaped. That is, they're streamlined so that in a sort of front to back fashion so that they can run very fast and chase down whatever it is they're trying to catch. Secondly, they have what I refer to as an armored front. Now, when they run up and try to catch animals, these animals usually start trying to kick the crap out of them. And so as a result, they typically have a heavily padded shoulders. Their chest cavity is protected. Their organs in their chest cavity is protected by the rib cage. The most vulnerable parts of these animals, the unprotected abdomen and the gonads, are way at the back, the furthest away from where the action is, so that they will be the least likely to be injured. They obviously have a thick, muscular, sturdy neck so that they can grab onto something and, shake it and rustle it and bring it down to the ground without getting whiplash or, breaking their neck. They have forward deployed weapons. Anybody that's looked into the face of a snarling dog knows exactly what that means. Those teeth that are designed to slash and cut and grab, and the claws are all up front so that they can do what they need to do to bring down their prey with a minimal of energy expenditure. Their top speed is usually somewhere around, with the exception of the cheetah, which is a special case, around 35 miles an hour. That enables them to ambush or capture sick, injured, or unwary prey. And they have what is referred to as a digitigrade stance. What that means is that they are standing on their toes, okay? So that they are permanently ready to run. You see, like you or I, if I challenge this young lady right here in the front row to a race, we'd have to get up on our toes to run. They're already on their toes. They're always ready to run. And the other thing that a digitigrade stance does is it increases stride length. Speed is basically stride length per unit time. So in other words, the longer your legs and the faster you move them, the faster you go. So by being on their toes, not only does that make them ready to run, but it also makes their legs longer so that when they take a stride, they are actually covering a greater amount of distance. Their nails are sharp claws, and those act like sprinter spikes, kind of grab the ground and gives them traction. The sharp claws are also used to grab onto and grapple with prey. They have permanently flexed joints, okay? Now, remember I had you guys standing with your legs bent? Well, you notice that that's very uncomfortable in a very short period of time. But these animals always have bent joints. Now, the good part about that is that they are essentially in a permanent runner's crouch. The bad news about that is that it takes a lot of energy for them to stand up. So as a result, if they're not doing something, they go lay down. That's why your dog and your cat, if they're not actively moving somewhere, playing around, they're laying down because it takes a lot of energy to stand. Because you see, for us, when we stand straight up, our body resists gravity using our skeleton. So that it's just my bones that are resisting gravity, which takes very little energy because bones are mainly inert. But if I'm standing like this, then my muscles have to resist gravity, and that takes a lot more energy, and I get tired a lot more quicker, and so do these animals. Or more quickly, my English teacher would say. Made that point. They have these skinny little legs. That's the other thing. Notice that they have skinny little legs. And why is that important? Because if you're going to be moving these things really fast, you want to have them as light as possible because that allows you to move them fast for a longer period of time with a lower energy cost. Now again, if I took, say, the first two people sitting up here, I'm going to pick on you guys all night, I just want you to know and I had them race each other, but I put heavy ankle weights on him and not on her. The first thing you say to me is, hey, that's not fair. My legs are heavier than hers. I'm not going to be able to run as fast as she can. So that's why they have these skinny little legs, because it makes it easier to run. And then you look at their senses. Their senses are adapted for finding the food that they need. So they have super acute hearing. I tell you, I have a black lab at home, and it's like when I come home, I work at night, and so when I come home, I'm pretty tired, and I usually go to sleep. But I never have to worry about missing a delivery package, because as soon as somebody rings that bell, she goes crazy. In fact, it's before they even get to the door. She's like at the door, barking, yelling, like, who the heck are you? Why are you invading my territory? And I'm like, Onyx, I love you because, you're the best alarm dog I've ever seen. But these animals have super acute hearing that allows them to locate prey over great distances. Their ears are actually swivel and can swivel independently, like little mobile radar dishes that allow them to find out where the prey is trying to hide. Their eyesight is optimized for night vision. So, again, you've noticed that when you shine a light into a dog or cat's eyes, it shines. That's because they have a layer of reflective cells at the back of their retina called the tapetum, which actually reflects light and allows them to see 6 times better than we do in the dark. And why do they need to see well in the dark? Because contrary to what the impression you might get from watching National Geographic or the Animal Planet or Discovery Channel, carnivores hunt mainly at night. Why do they do that? It's that energy efficient thing. Most of the plant eaters are sleeping at night, so they are easier to catch. So they hunt at night. Their eyes are also optimized for the following movement. Now, if you look into the human eye, we're going to discuss this a little bit more when we get to the part on humans. The most acute vision in our eye is at the back of a retina and a little spot, a little dimple called the fovea, which is where we have the greatest concentration of high acuity receptors. You don't find foveas in carnivores' eyes. They have what's called a visual streak. It's a linear line along the back of the retina where their most acute vision is, but what that does for them is it allows them to track movement very well. And obviously, if you're going to be chasing something, that's something you want to be able to do. Now, the downside is that they have low resolution. They don't see detail very well. And again, if Onyx was here, she'd probably ask me for a fee because I'm using her as a lot of examples. But when I first got her, I live in an apartment that opens out into a green area, and so I have a walkout patio door that has a screen on it. Well, when she first got into the house, she's actually addicted to squirrels. I have to admit that. Some people have a problem with drugs and alcohol. She has a problem with squirrels. And every time I would pull the glass back, when she would go charging out after the squirrels, and she would knock the screen off the door because she couldn't see it. Well, finally she learned, hey, there's a screen there, and she would wait for me to open the screen. But her eyes were not sensitive enough to actually resolve the mesh because they don't have good resolution, fine discrimination. The type of retinal cells that you use for fine discrimination are cones. The type of retinal cells that you use for detecting a vision in low light situations are the rods. In carnivores' eyes, they have mainly rods, very few cones. In our eyes, we have mainly cones, very few rods. Oh, excuse me, I'm jumping ahead, forgive me. All right, then their sense of smell is like awesome, it's off the chart. As anybody knows, has anybody here ever escaped from jail and been tracked down by bloodhounds? No. Their sense of smell is amazing. They can actually track a trail from someone that's several days old, in fact. Their sense of smell is estimated to be over 400 400,000 times more powerful than ours. And it's also sensitive enough for them to detect and track prey at great distances. But this is what's really cool. They can also identify animals that have cancer or some kind of infection or some kind of metabolic disorder. See, it used to be that people thought that these animals were just going out and hunting randomly. That's not true. They actually go out and first they try to get a herd of animals moving to see which one is limping or which one is not paying attention. But if that doesn't work, then they start sniffing the air to find out who's sick, who's got a problem. And we, as humans, are finding ways to utilize that ability by training dogs to detect people with early forms of recurrent cancer. They're now training dogs to detect people with melanoma when it's at such a early stage that we could never detect it with an MRI or a CAT scan, but they can actually smell it before we're able to detect it. And what people have come to realize is that these animals are actually able to pick out the prey animals that actually have some sort of an infection and that are sick, and those are the ones that they go and chase. Why do they do that? Because they're easier to catch. Again, they don't want to spend a lot of energy looking for something that's able to run away from them very quickly or that's healthy, because they're likely to not be successful. Carnivores are also remarkably sedentary. They usually sleep up to 20 hours a day. Again, if you have a pet, you know that. Such economy of movement helps them conserve energy during the long periods between their meals. Talking about wild animals here, because most of our domestic animals are a little obese. And it also reduces the energy penalty of their flex joint digitigrade stance. In other words, by laying down all the time, they're not using muscle energy to stand up. So remaining sedentary during daylight hours also helps them avoid overheating during the hottest part of the day, since most of them are wearing fur coats. And again, when I have to let my dog out during the wintertime to, handle her business, she likes to run around in the snow and play, and I'm like, look, you got a fur coat on, I don't, hurry up. All right, we're gonna look at a carnivore skeleton here. And again, what you see is that flex joint stance I was telling you about. This is a picture of a wolf, and the fact that it's standing on its toes, the digitigrade stance. This is just another picture of some more carnivores showing that they all have the same type of body structures: the wolf, bear, hyena, and a tiger. Flex joints, standing on their toes. Although the bear is a little more flat-footed because it's actually more of an omnivore than a strict carnivore. Now, here's something that's really interesting. A skeletal feature that is peculiar to carnivores is the presence of something called a baculum or a penis bone. The males have bones in their penis. And a penis bone is present in all carnivores except hyenas. And despite the rather vile slang term that people sometimes use for having sex, men, we don't have one. And the bacula that are shown here include those for foxes, raccoons, lions, and tigers. Well, let's look at the carnivore body plan. Now, in human beings, our center of mass or center of gravity, the point in our body at which it feels like our weight is balanced, is way down here in our pelvis. And that's a problem if you're playing football and you're trying to tackle someone, because you hit with the upper body. So a lot of times people, try to fly at someone to try and get. Oh, I got one. Thanks, Joe. To sort of, get their center of mass in line with their direction of movement, because clearly that's what allows you to develop the greatest force. Actually, if you look at these animals, their center of mass is right here, right in line with the direction they're moving, so that when they're running, chasing something, and they're accelerating, and they leap on that animal, their full 300 or 400 pounds is, times the speed, F, which is force equals mass times acceleration. So their mass of 300 or 400 pounds, and their acceleration is multiplied together to give them a great takedown force, something that we don't have because our center of mass is actually, how many had physics? Well, if you actually did vector forces on me running, you'd see that when I was running, I had part of the vector force going that way, but part of it going down that way because I'm standing upright. So I can't get the full force of my however many pounds I weigh, which we won't discuss that, in line with the direction I'm moving because of the way that I'm designed. Well, what about the plant eaters? Herbivores, as I said before, are designed for foraging and can walk long distances at low energy cost. As a result, and they tend to remain active throughout daylight hours. They often live in large, multiple family social groups, whereas carnivores, by and large, are solitary with the exception of wolves and lions. And what you find is that instead of being bent, their limbs are actually very straight so that they can stand up all day at no energy cost. Okay, because they got to stand up when they're walking around looking for that food. Some of them are so well designed, like horses, they can even sleep standing up with no problem whatsoever. Their limbs are further lengthened and extremely lightweight. So, you saw that the wolf's limbs were lightened, but when you look at these animals, they have almost stick-like little limbs because unfortunately, sometimes they get chased by these predators and they need to run away, so they need to be able to move their limbs faster than the lion or the wolf can. So their limbs are further lightened. And they have what's called an unguligrade stance. And that's why they're called ungulates. What that actually means is that these animals are standing on the tips of their, I'm not Pee Wee Herman, so I can't do it. But they're standing on the tips of their toes like a ballerina. So whereas the carnivores are sort of standing on the balls of their toes, these animals are literally standing on the tips of their toes. And standing on the tips of the toes maximally lengthens their stride length, which is what allows them to actually be a little more speedy. Instead of claws, their nails are flat and blunt. They may have color vision. Why is that necessary? Well, you see, it doesn't matter what color an antelope or a deer or a jackrabbit is. If it's moving and it's alive, it's edible. But when it comes to plant food, it sometimes does matter what color it is, because if it's green, it's not right. But if it's red, it is. So if you're going to eat plants, you need to know when they're edible. Because plants often put indigestible compounds in their unripe fruit, because fruit is designed to basically broadcast their seeds, and until their seeds get ripe, they don't want you eating their fruit. So they leave the fruit green, and when the seed is fully ripe, then they turn the fruit red. You know that it's ripe, and it's good to eat. But again, it's not important to a carnivore. If you got a bunch of deer and painted them all blue or purple or striped or polka dot and put them out on a savanna, trust me, if they were stupid, they'd be eaten. These animals, again, are most active during the day. Their top speed is usually in excess of 45 miles an hour. They use speed and endurance to escape predators. The other thing about predators is that they can run 35 miles an hour, or even in the case of the cheetah, they can hit 70 miles an hour, but only for a very short period of time before they got to stop and catch their breath. But these animals can run for long distances, which is why we hooked up, horses to stagecoaches and not cheetahs. They use horns, hooves, and antlers, aid in defense against predators. By the way, I want you to notice that I'm calling this group of herbivores vulnerable herbivores, because these are the ones that are sometimes preyed on by other animals. And they use something called pronking to signal that I'm too strong to catch it. Again, if you are kind of a cable news channel or cable news show junkie like me, watching Animal Planet and the National Geographic Society, you notice that sometimes when the animals or the cheetahs start to go out to hunt, like the springboks start, bouncing around like this. What they're doing is they're signaling, look, don't waste your time chasing me because I'm gonna dust you. But my friend over here, he's got a sore foot, so you might want to, you might want to track him down. In fact, there's a kind of a funny story about two guys who went out to camp, and one of them looked up and he said, "Oh my God, here comes a bear!" His friend immediately sat down and started putting on his track shoes. And he said, "Why are you doing that, you fool? You can't outrun a bear." He said, "I don't have to. All I have to do is outrun you." So the young are born without scent, and they lay motionless so that they will be invisible to predators. For a long time, I didn't understand that. But when I realized that predators have very poor discrimination in terms of their ability to see detail, that their eyes are designed to detect movement, and that they use primarily their sense of smell to locate prey, it made sense all of a sudden. And there are there's actual film of lions and hyenas walking right past baby antelope on the African savannah that are laying perfectly still because they can't smell them. And as long as those babies don't move, they can't see them, discriminate them from the background grass. And that's why these animals are born without scent. Well, let's kind of talk about the fact that these animals are actually not that vulnerable. Now, this is a chart that looks at the outcome of 120 different moose hunts by a pack of 15 to 16 wolves in a national park in Canada. And the bottom line is that 95% of their hunting attempts were unsuccessful. And this is a little difficult to see, but basically, this is 120 moose were detected and stalked. So they gave chase. Of those, 20% of the moose stood at bay and said, "You come any closer, I'm gonna kick you to kingdom come." And the wolves left them alone. Because wolves are bigger than horses, and moose are bigger than horses, and most wolves have pretty good sense. But 80% said, "You know what, it's not worth the aggravation, let me try and get out of here." And they started running. The wolves gave chase. So they ran for a while, and then afterwards, I think it says 26% of them said, "You know what," 26% of them, the wolves never caught up because the moose just outran them. But 44% continued to run, and then 10% of those said, "You know what, I'm tired of this." And they turned around and said, "If you come any closer, I'm gonna kick you to kingdom come." And the wolves left them alone. Okay, so now we're down to 34% continued to run. Of those, another 28% eventually outran the wolves because they have better endurance. They outlasted them. And so in 6% of cases, the wolves caught up and attacked them on the run. Of that, 1% were wounded but ultimately escaped, so that ultimately only 5% of the chases ended in an actual kill. Studies show that when you actually, and people have actually done this, they've gone in and looked at the carcasses after the animals have finished feeding, and they realize that these animals are generally old, lame, they're either sick, they have cancer or some other problem, or are diseased in some way, so that what they realize is that these weren't random chases, that these animals were actually that the predators were actually picking animals that were some way compromised. So the net effect of carnivore hunting strategies is to strengthen the gene pool of their prey species. However, the low level of successful hunting means that carnivores can only exist in relatively small numbers because they're at the top of the food chain. Again, remember that fact, it's going to become important later on. As a question I want you to ponder. If someone stole your food 95% of the time that you attempted to eat, how could you avoid starving to death? I just told you that 95% of the time that carnivores try to eat, they come up empty. Why are there still carnivores left in the world? Keep that question in mind. All right, moving on, let's talk about the invulnerable herbivores. These are the ones that are so large and powerful that they are essentially immune to predation, like elephants. You know, when people get ready to film tigers over in India, they ride around on elephants because the tigers will not come near an elephant because they will get their butts kicked. So these animals have no need to be fast because they don't have to run from anybody. Their top speed is usually somewhere around 25 miles an hour or so, or maybe 30 in the case of a rhino. They usually are active during the day, looking for their food, walking around, you know, kind of going from this store to that store, Safeway, Giant, whatever. But interestingly, since they don't have to run, notice they don't have those little skinny stick-like limbs. They've got thick, pillar-like limbs that help support all of that bulk and weight, okay? They often have a largely hairless skin. Starting to sound familiar? Their nails are flat and blunt, not claws. And they may have a flat-footed type of stance or plantigrade stance. And what we find is, like humans, elephants are long-lived social animals that live in family groups of various sizes. In general, herbivorous mammals live significantly longer than carnivores. So let's compare some limb structure. And this is a cat sized up to an elephant size to make it really clear the difference in the limb structure. You see how straight this is? You see how the limbs are underneath the body to support the weight, the body weight like a table, whereas here in the cat, they are bent and sort of out front, gives them more mobility, but again, takes a lot more energy for that animal to stand up. So when it's not hunting or playing or doing something, it's laying down. Well, what about us? Humans are designed for walking and foraging because we're lousy runners. I mean, we have the Olympics and all that, but trust me, almost a jackrabbit would leave us in the dust. Instead of having a protected anatomy, we have a completely exposed anatomy. The most vulnerable parts of our body, the unprotected abdomen, no bones to shield those organs, and fellas, the gonads, right up front where they can be kicked to kingdom come. And believe me, your gonads get kicked to kingdom come, you don't make any little copies of yourself, your genes don't live on. Instead of being streamlined for running, we have a flattened, non-aerodynamic body and this sort of skinny little flexible neck. It allows us to turn this great big head we have, but it also makes us prone to things like whiplash when we're in violent situations or getting our neck either snapped, broken, or sprained. We have straight, heavy limbs just like the invulnerable herbivores. We don't have skinny little legs. We have very heavy legs. And our largely hairless skin is used to cool our huge brain. Now, again, I got to try to cram a lot into this whole talk, so there's a lot of stuff I can't go into in the sort of detail that I would like to. Where are you? Oh, come on. Thank you. But suffice it to say that our brain weighs about 3 pounds, 2 to 3 pounds, which is typically 2 to 3% of our body weight. But yet that part of our body gets 20% of your cardiac output and uses 1/4 of the energy that you burn up every single day. So that means that if a lion, which typically weighs about 300, 350 pounds, had a similar sized brain, its brain would be 3 times the size of ours. If an elephant had a similar proportion brain as ours, their brain would weigh 320 pounds, because elephants are usually somewhere around 6 tons in body weight. And that means that this is the most metabolically active tissue in your body. It's putting out a lot of heat, but since it's surrounded by bone, the only way to get rid of that heat is to get it out of the skull, send it out to the skin, sweat, cool off to keep it cool. Our nails are flat and blunt. Lifestyle factors, that is living in social groups, being active during daylight hours and sort of, getting to safety at nighttime, make us relatively invulnerable to predation both on the savanna and in the city. And our slow speed and poor endurance are most useful for not chasing down prey, but I will argue that it's most useful for escaping stinging insects. Now, the caption reads, "It was foolish for Russell to approach the hornet's nest in the first place, but his timing was particularly bad because if you notice, he was there at angry hour." The top speed of bees and wasps is about 20 miles an hour. Fastest human beings sprint about 19 to 24 miles an hour, and women are roughly as fast as men. Stinging insects will usually only chase you about 100 meters away from their nest. And we know from watching the Olympics that the maximal human sprint lasts somewhere between 100 to 150 meters. Even in a 200-meter dash, for that last 50 meters, those people are slowing down because they're running out of gas. So what that makes clear is that our running ability is most consistent with escaping threats met foraging, typically from insects, but not with preying on other animals. You know, someone once said human beings were only meant to run away from danger and to the bathroom, and I think they were correct. Well, when we actually look at women, what we see is that pregnancy and a woman's lower upper body strength clearly make Stone Age type hunting impractical, if not impossible. So the way anthropologists have responded to that is that they've said, oh, well, you know, the women were dependent on the men to, you know, kind of go out and hunt and bring home the food. Really? Nowhere in nature is there any female animal that is dependent upon the male of the species to bring her food that she needs to live and raise her young. And that's because, fellas, I'm sorry, but women, I'm sure you know, men are notoriously unreliable. The long gestation period of humans is typical of herbivores, the plant eaters. We're going to see that in greater detail in a minute. But this is what's really interesting to me. Human embryology suggests that being an herbivore was a necessary prerequisite for human brain development. Now, I will tell you at the outset, I believe in God and I believe we were created as we are, but since I deal with knothead scientists who won't pray and won't try and even contact God, I have to talk to them about evolution so that they will respect what I say. But I think that even using the evolutionary argument, it's clear that we had to be herbivores in order to have the brain that we have, and I'll show you that in a minute. Single births are the rule with humans, and the baby birth weight is 6 to 8% of the mother's body weight. Again, typical for the plant eaters. And when babies are born, their eyes are open. And most of you probably have kids, so you know that already. Me, when I was in medical school and I saw the baby come out and it was looking around like, who are you guys, and why did you drag me out here? I was just like really blown away. It was an awesome moment. But anyway, let's look at the length of gestation in weeks. And what you see are dramatic differences between the meat eaters and the plant eaters. And this down here says that the data listed are for non-marsupial terrestrial mammals more than 40 kilograms in adult body weight. And the reason is that I needed to obviously restrict this to animals that were similar in size to us. It was no point in comparing ourselves to whales, and there was also no point in comparing ourselves to kangaroos because they have, babies that kind of are pre-born, then crawl into a pouch and develop there, and we don't have a pouch. But there was also no point in comparing ourselves to elephants because elephants have a 2-year gestation period, and part of that reason is because they're gigantic. Their babies weigh 300 pounds at birth. So we're looking at animals that are roughly within our size range. And what you notice is that carnivores have extremely short gestation periods. The typical carnivore gestation period is about 13 weeks. The longest is around 15 weeks, much shorter than the herbivores. At 13 weeks, the human embryo barely has the beginnings of a nervous system. So you remember what I said about human brain development? If human infants were born at this stage, you wouldn't have the brain that you have. Because at that age, the human embryo has but the beginnings of its brain. And when a baby is born, it has all of the brain cells it will ever have. The increase in size in the central nervous system after birth is due to the increase in size of individual neurons and also the wrapping of the axons of the neurons by myelin so that they become more efficient in transmitting signals. It's not by making new nerve cells. So you've got to remain in utero the 9 months so that you will have the brain that we have. So you see, these animals could never have a baby with a brain like a human's because they don't stay in utero long enough for that brain to develop. But typically, you look at the plant eaters and you see the average gestation length is greater than 35 weeks. Whereas carnivores have multiple babies born at one time, the herbivores have single babies born at one time. Bears may have delayed implantation, but their actual gestation period after implantation is about 13 weeks. All right. The short gestation and low birth weight of carnivore neonates is important because it enables the pregnant mothers to continue to hunt. So you see, the female lions don't go lay under a bush and say to the male lion, bring me something to eat. They got to get out there and do their own work. And so as a result, they can't be heavily pregnant with a giant baby trying to chase something down because either they wouldn't catch it or the baby might be injured. So they have these very, very small babies born at a very early stage of development so that they can continue to hunt. By the way, this chart shows you the birth weight of the babies as a percentage of the mother's body weight. And this is astounding. Look at the carnivores. Tiny babies. Look at the plant eaters. Huge babies by comparison. Much bigger percentage of the mother's body weight. And I don't have to tell you in which group we fall. Carnivore young are born, as I said, their neonates cannot regulate their own body temperature, and their infants are born with their eyes closed because their neurologic development they're still undergoing neurologic development. Herbivore human infants are born with their eyes open. Eye opening is a gauge of the extent of brain development. Herbivore and human neonates contain 20 to 30% more energy per gram than carnivore newborns. Herbivore and human gestation length, birth weight, and singleton births, that is single birth, represent a much larger maternal investment in each offspring. All right, let's look at the differences, and we're going to quickly look at the differences in the kind of milk that various animals feed their young. Because they are born at a very early stage of development, carnivore infants require milk that is much more rich than herbivore and human milk. And the representative herbivore is the cow, and humans are down here at the bottom. But you can see huge differences in total solids, percent fat, protein, and so on and so forth. Carnivore milk contains more than 2 to 10 times as much fat as herbivore human milk. Carnivore milk contains 2 to 4 times more protein than herbivore and human milk. But I also just want to make a point about cow's milk, that cow's milk contains nearly 3 times as much protein as human milk. And I'm going over this because I want you to understand why you should not be feeding your babies cow's milk. Cow's milk is made for baby cows, not baby humans. A cow is about 80 pounds at birth. By its first birthday, it weighs somewhere around 600 pounds, unless it's been given steroids and growth hormone and all that other crap. And so they have a milk that's designed to get them to that body weight in that year's time. Bovine, that is cow's milk, proteins are qualitatively very different from the proteins in human milk. And although the percentage of fat in human milk and cow's milk is similar, the composition of that fat is very different. The fat in cow's milk is much more saturated than the fat in human milk. That's why you can make butter and ice cream from cow's milk, but you can't do it with human milk. They're very different substances. Well, let's move on to talk about the head and neck region. When you look at carnivores, they can open their mouths real wide because obviously you have to run up and grab something in order to wrestle it to the ground. So they have reduced facial muscles that allow them to open their mouths very wide and grab onto prey. The temporalis muscle, which is the muscle that sits on the top of the head, is gigantic, and it's the main muscle operating their lower jaw. And that's important because it basically keeps that lower jaw stuck in the socket so that when they grab onto something, their jaw isn't dislocated because there are no ENT surgeons on the savannah. You dislocate your jaw, your history. Their teeth clearly are designed for ripping, tearing, and cutting. They do not chew their food. Say it with me. They do not chew their food. You know, your mom used to always say, take your time and chew your food. At least my mother did. Their mother never says that because they don't chew. They just rip off a hunk of flesh and swallow it. No need to chew. The jaw, as a result, has minimal side-to-side motion and doesn't move backwards and forwards. Their saliva has no enzymes in it because the stuff that they're eating is protein and fat. If they released enzymes that digest protein and fat into their mouth, they wouldn't have a mouth for very long. Now, looking at the jaw mechanism more closely, what you see is that the jaw joint is on the same plane as the teeth. And that allows as the cheek teeth. And my little pointer keeps going in and out. You see how these upper molars slide completely past the lower ones? This allows the jaws to act like a pair of shears, slice flesh off bones, cut through tough hides and tendons and so forth. This area called the angle of the mandible, which is where this area right here in these animals is reduced because there are two muscles that attach here. One is called the masseter, the other is called the pterygoids. Very small because those muscles are very unimportant to carnivores. They're going to be very important, as we shall see, for the herbivores. But the temporalis, that's the muscle that sits in this big hole up here. Come on, don't. Step and fetch it. Please don't fail me now. Okay, here we go. This area up here is where the temporalis muscle sits, and it attaches right along here, and again, pulls that jaw into the socket, keeps it very stable. When you pet a dog, you're not actually petting its skull, you're petting its temporalis muscle. Carnivores have extremely powerful jaws. Their jaws are capable, and this allows them, again, to wrestle animals weighing half ton or more to the ground, dismember them, and crush their bones. If you look at estimated bite forces, dogs have a bite force of 300 to 450 pounds per square inch. Wolves, it's more than 500 pounds per square inch. The jaguar has been estimated, at around 700. Lions and tigers, 800 to 900. Hyenas are greater than 1,000. By contrast, we can barely muster 135 to 150 pounds per square inch, because obviously we shouldn't be trying to crush bones. Well, when you look at the plant eaters, very different story. Instead of reduced facial muscles, they've got well-developed facial muscles. They got all kinds of facial muscles, which allow them to make all kinds of expressions like, ugh, I don't like the way that smells, or I'm pissed off at you. They have a small opening into their oral cavity, but anyway, I'm jumping ahead. The masseter muscles, which are the muscles that attach on that expanded angle of the mandible, attach on the outside. The pterygoids actually attach on the inside version and hold the lower jaw in a sling-like arrangement. If this is the masseter, this is a pterygoid, one pulls this way, the jaw moves that way, one pulls this way, the jaw moves back, so that the jaw has a nice side-to-side motion. I want everybody to kind of put your hands right here and bite down. You feel that bulge? That's your masseter. Put your hand right here and bite down. You feel that little bump? That's your temporalis. But again, I'm jumping ahead. All right. The jaw joint, and this is really critical. Now, you remember with the meat eaters, the jaw joint's in line with the teeth so that the teeth are acting like a pair of shears. Here, the jaw joint is above the plane of the teeth, giving the lower jaw an L shape so that when it closes, the teeth come together like a nutcracker, one on top of each other. But what it also allows is a more mobile side-to-side and backwards and forwards movement. And that's because they don't need stable jaws. They're not trying to grab something with their mouth and wrestle it down, but they are trying to crush up and grind plants, so they need a jaw that allows them to grind up plant food. This mobile type of jaw structure is only found in animals that have committed to a plant food diet because it can be easily dislocated because, as I said before, no ENT surgeons on the savannah. This type of jaw structure is so important for processing plant foods. It is theorized to have independently evolved in 15 different times over the course of a mammalian evolution. The teeth are designed for cropping, that is the incisors, and the molars are designed for grinding. And as we have seen, the angle of the mandible is nice and expanded to provide area for large master and pterygoid muscles. The lower jaw has pronounced side-to-side motion. It can also move forward. These movements allow the grinding actions of chewing. The tongue is thick and muscular, and this aids in chewing. And these animals often have an enzyme in their saliva called salivary amylase, which begins the process of digestion of carbohydrates while food is still in the mouth. Now, this is interesting that all that well-developed facial musculature gives these animals a very small opening into their mouth. And what that means is that because they have a small walled-in oral cavity, they can create a vacuum and suck up water, whereas the carnivores have to lap it up. How do you drink water? Do you have to lap it up from a dish? All right. Carnassial teeth, which are the cheek teeth, and the carnivores are like little jagged steak knives. They come together, form a shearing surface that allows them to cut meat off bones. By contrast, in the plant eaters, the molars are flattened and nodular, sit on top of one another for crushing and grinding. When you look at how the teeth work when the jaw is in motion, you see that carnivores' molars slide past each other vertically when the jaw is closed, whereas with herbivores, these molars slide across each other horizontally. All right, looking at the esophagus, which is the tube leading from the mouth to the throat. In carnivores, the esophagus is wide and easily distensible. They can swallow huge chunks of meat without choking. And interestingly, they have voluntary muscle along their entire length. Now, again, when I was a kid and my mom used to give me meat scraps for my dog, and I would go out and feed it to her, the dog would just take it and swallow it. And I was always so scared it was going to choke, and it never did, of course. But more importantly, I was like, you didn't even taste that. You just swallowed it. And this thing about the voluntary muscle along the entire length means that they can regurgitate food at will. But that's important because what happens when they go out and hunt and wolf down a bunch of meat? They go back to where their babies are and they regurgitate it so that the babies can eat as well. Now, we don't have voluntary muscle along the entire length of our esophagus. You know that once you initiate the process of swallowing it, it's over with. I mean, there's sometimes you probably wish you could bring something back up, but unfortunately we can't. With herbivores, the esophagus is narrow and muscular, and they have to swallow a small bolus of food. Same thing with humans, narrow, muscular. More than 90% of the people who choke to death every year choke while eating meat. That's from the ear, nose, and throat medical literature. And let me just say to you that if you ever find yourself in public and you start to choke, do not get up and go to the bathroom, because that's where people die of embarrassment. Seriously, people, unfortunately, they will start to choke on something, they get up and run out to the bathroom because they don't want to be embarrassed, and then there's no help in there, and they end up losing consciousness, choking to death, and then people find them on the floor. Just be embarrassed and get the Heimlich maneuver and go on about your business and leave the meat alone. All right, so let's talk about the upper gastrointestinal tract. Animal tissues this is a picture of an animal cell, and basically what an animal cell is comprised of is a cell membrane made up of sort of fatty acids, and then the interior is full of proteins, a little water, and some other stuff, okay? So that animal tissues very easily and quickly digested, mainly proteins and fat, no cell wall, no fiber. Therefore, meat eaters do not require a long, elaborate digestive tract. Now, the carnivore stomach. I want you to recall that question I asked you to ponder a little while ago. The carnivore stomach is extremely acidic with food. The pH, when it's full of food, is less than 1. That's as strong as battery acid. And that's important because it allows these animals to dissolve bones, hooves, tough connective tissue, hides, and so on and so forth. But the other amazing thing about their stomachs is that they are gigantic. They are extremely large. The carnivore stomach can hold 60 to 70% of the total gut capacity. That allows them to eat 20 to 30% of their body weight at one meal. Let me repeat that. It allows them to eat 20 to 30% of their body weight at one meal because their stomachs are designed for intermittent feeding. Remember, I pointed out, I showed you that they're 95% of the time they hunt, they're not successful. So they may eat today and not eat again for another 7 to 10 days. So they need a stomach that allows them to eat as much as they possibly can today because they don't know when their next meal is going to come around. And that brings up the concept of recoverable energy. The huge capacity of the carnivore stomach is necessary to make hunting practical due to hunting's inherent inefficiency. A stomach that can hold 20 to 30% of an animal's body weight means that at a single meal, a 50-kilogram wolf can eat up to 15 kilograms of meat. Now, if you calculate the calories at 1.41 calories per gram, and that figure actually comes from a study done by Dr. Boyd Eaton on African game animals versus African wild plants, you find that that means that that animal can consume 21,000 calories at one meal. That's just off the chart. That's enough energy to recover the vast amount of energy expended during unsuccessful and successful hunts and last for several days until their next kill. So that's how they're able to miss a meal 95% of the time and still remain alive. Moreover, because of their ability to eat carrion, that is rotting, bacteria-laden, nasty, wormy, stinky food, carnivores can recover additional energy from a single successful hunt over the course of several days if they can fend other animals off their prey. So, they basically eat what they can, and then they stash the rest of it under a pile of leaves. And while it may keep the other lions or the hyenas or the coyotes away from it, or if you're a leopard, you drag it up a tree, the flies don't have a problem. They just kind of go lay their eggs. So there's usually maggots and everything else crawling over it. And the bacteria have a field day. Hey, they don't have no problem with that because remember, they got battery acid stomach. They can kill anything. So they're not worried about food poisoning. When you look at their small intestine, it's very short, usually only about 3 to 4 times their body length. The enzymes that line their protein and fat digesting enzymes, they're able to go for long periods between meals without having the mucosa involuting and becoming non-absorptive. Now, if any of you go more than 3 to 4 days without a meal, you cannot sit down and eat a full meal without getting sick. And in fact, this was found out tragically at World War II when American soldiers were liberating the concentration camps, and they saw all of these starving people, and they were obviously, emotionally moved and started giving them all kinds of food. And the people were so hungry, they started eating, and a lot of them actually ended up going into shock and dying. And the reason is that when we don't eat for several days, the cells that line our intestine lose the ability to retain water while absorbing nutrients. And as a result, what would happen is they put all of that food into their intestine, which has what's called osmotic pressure. It pulled fluid from their bloodstreams into their stomachs, gave them diarrhea, caused their blood pressure to drop too low, and they went into shock and died. So that's why if you have abdominal surgery, you know anyone that has it, what happens is the surgeon says, first you got to start with clear liquids, then you move to full, and that usually means Jell-O, for God's sakes, and then you move to full liquids, and then finally to food, because what that does is that stimulates those cells to start maturing so that you can eat without losing all of your body fluids. And it has a poor capacity to digest and absorb moderate to large amounts of carbohydrate. And this is just a picture of some different carnivores showing very simple digestive tract, huge, simple stomach, small intestine, simple, large intestine. All right. Well, let's make an obvious point. Plants don't have bones. Instead, plants use cellulose to resist gravity. Therefore, all unaltered plant tissues contain indigestible cellulose. And the reason is that when you look at the plant cell, they not only have a cell membrane in here, they also have this thing called a cell wall surrounding every cell, which is made up of the cellulose that we talked about. But this means that because these tissues, plant tissues, have all of the cellulose, they require prolonged digestion, and they're comprised of protein, fat, carbohydrates, and fiber. So I'm sure anybody who's ever told someone I'm a vegetarian or we're supposed to be plant eaters, the first thing they said to you is that, well, if we're supposed to be vegetarians, how come we have 4 stomachs? Have you ever heard that? I mean, people used to say that to me all the time. And I would say, well, because I'm not a cow like you. But anyway, not all plant eaters have 4 stomachs. Only the foregut fermenters. Now, remember I said at the beginning that cellulose is made up of sugar molecules. It's just a different bond, except we don't have the enzymes to break those bonds. Guess what? Bacteria and protozoa do. So what these foregut fermenters do, like antelope and cows, is they got a big soup in here made up of protozoa and bacteria, and they release enzymes that can digest their cellulose. So they then, swallow a bunch of grass, let it go down there and soak up that enzymes. Then they bring it up and do what? Chew the cud. The purpose is to mix those enzymes with the food. The purpose of chewing is to mix digestive enzymes with food, okay? And then as a result, the cellulose starts to break down, it goes to these different chambers, and ultimately comes to the colon, where it's acted on by additional bacteria, and that means they have very efficient digestive tracts. Whereas other herbivores, like horses, have a simple stomach. Now, horses typically eat food that has a lot more intrinsic nutrient value than like cows or antelope. So horses eat things like seeds, like oats, and so on and so forth. And what they do is they extract all the nutrients out up front. Then the leftover fiber, they have bacteria back here in the colon that act on the fiber, break it down, and they extract additional energy from it. So what you see is that in the multi-chambered herbivores, it holds about 30% of the total gut capacity. The pH is neutral to slightly basic. It's designed for batch feeding, meaning they don't eat intermittently. They have to eat several times over the course of the day. As I said, the chambers house bacteria, but key point, in foregut fermenters, cellulose utilization is more than 60%. That is very efficient. That's why they pass a semi-liquid stool. If you've ever seen a cow patty, you know what I mean. The herbivores with the simple stomachs, again, about the same size, holds about 30% or less of the stomach capacity, mild to moderate acidity, 4 to 5 pH, designed for batch feeding as well. In other words, they have to eat multiple times over the course of the day, cannot hold enough calories to last even for one day. Therefore, they have to eat several times to meet their caloric needs. Small intestine is extremely long, 10 to 12 times body length or more. Extended length allows sufficient time and surface area to extract absorbable nutrients from the fibrous plant material, and they have an adjustable mix of carbohydrate, fat, and protein digesting enzymes, unlimited capacity for carbohydrate digestion. This is some examples. I'm just starting to move fast, make sure we get through everything, folks. Let's talk about lower digestive tract. When you look at the carnivore colon, it's essentially very straight, short, simple, and that's because by the time whatever residue gets to the colon has no nutritive value, they just need to get it out of their body before it putrefies. Its only function is elimination. Lack of fiber means that any bacteria that are in the colon can only use that protein residue as an energy substrate. And as a result, they would make toxic metabolites like ammonia and other vile things, which could poison the animal. Therefore, they want to get that stuff out of their bodies as quickly as possible. Contrast that with the plant eaters. You have a very long and elaborate colon. This is a horse, this is a rhesus monkey that often has a pouch structure, and the reason that it has pouches is to increase the capacity, and it has several functions, including water absorption, vitamin production, and ultimately elimination. Now, the interesting thing is that in the hindgut, that is the animals that ferment their fiber in their hindgut, the cellulose utilization is less than that of the foregut fermenter. It's only about 45%, and so they pass a fibrous stool. So think about the difference between a cow patty and horse poop. Horse poop is very fibrous, cow patty is semi-liquid. All right. This says, God rained down on them manna to eat and gave them the grain of heaven. Mortals ate of the bread of angels. That's from Psalm 78, verses 24 to 25. And now we're going to talk about us. All right. When you look at human teeth, what you see is that our incisors are spade-like, good for cropping and peeling. Our canine teeth are reduced in size and function as accessory incisors. The molars slide across each other horizontally like the other plant eaters. When you look at the human jaw, our jaw joint is well above the plane of the teeth. The angle of the mandible is expanded. This is where the masseter is attached on the outside, pterygoids on the inside. Molars are flattened and nodular for grinding. The lower jaw can move forward and side to side, allowing the rotary actions of chewing. To do a little comparison here, you can see that we have a jaw like the horse. Jaw joint above the plane of the teeth, expanded angle of the mandible, flat nodular molars. And notice that horses even have these small little teeny canine, as do a lot of plant eaters. By contrast, with the meat eater like the dog, the jaw joints on the same plane as the cheek teeth, acting like a pair of shears. And let's see, the temporalis muscle is obviously the main muscle of operating the jaw. Angle of the mandible is not expanded, and their canines are long and dagger-like. And then I asked the question, whose teeth are most like ours? The answer is obvious. Again, looking at our facial muscles, we have well-developed facial muscles, small opening into our oral cavity, a walled-in oral cavity, and fleshy muscular lips. Now, I know you thought your lips were there so you could kiss somebody, but anyone who's wrestled with an unruly piece of spaghetti knows that they're actually fleshy and muscular so you can get food into your mouth. Kissing is just a fringe benefit. Cheek muscles also help us chew, because as we push food into our cheeks, we push it back between the teeth, and as you saw before, your temporalis muscle is reduced in size. Let's just talk a minute about our eyes and vision, because another thing people always come up with, they say, well, the reason we have binocular vision is because we're supposed to be hunters. Oh, God, I was going to say I want to choke people when they say that, but I guess that's not nice. Not true. Because as we discussed before, our eyes are very different from carnivore eyes. Yes, we both have binocular vision, but we use it for very different reasons. Again, we have very poor night vision, whereas the carnivores have very good night vision. When you actually look at the human retina, we have trichromatic color vision. And we have a fovea, that dimple in the back of the retina where all of the cones are concentrated, that allows us to see in great fine detail. Now, this is hummingbird versus eagle analogy. What do I mean by that? What I mean is that saying that the fact that humans and carnivores have binocular vision, therefore we must do the same thing, is like saying, well, an eagle and a hummingbird has wings, so they must eat the same food. Not true. They use them for very different purposes. Okay, this is an inside view of our oral cavity. You see that we, again, nicely walled in, masseter and pterygoid muscles. This is the pterygoid muscle, which is analogous to this masseter here, outside and inside, holding the lower jaw into a sling-like arrangement. The structure, saliva contains the enzyme salivary amylase, and that's produced by the parotid salivary gland, which is shown right there. Our tongue is thick and muscular, aids in chewing and in speech. And what's interesting about the human pharynx is that, as you know, 90% of your sense of taste comes from your nose, not your tongue. And that's because as we're eating, the food molecules travel up the back of the throat into the nose, and that's what we're actually sensing. And so it's unlikely that any other animal on Earth tastes food the way we do, because no other animal has the same structure in the pharynx, and that includes the great apes. And that is important for reasons I can't go into. And the structure of our pharynx also helps us with speech. As mentioned before, when you look at the esophagus, it's narrow and muscular and only has a small ball of food. And 90% of the people who choke to death every year choke while eating meat. Gastroesophageal reflux disease, or GERD, is a major health problem, and it's usually caused by diets that are high in meat and fat. When you look at the human stomach, moderately acidic with food, only about 4 to 5, same as a horse, holds less than 25% of entire GI capacity. Again, designed for batch feeding. Based on the energy content of wild plant foods, which is 1.39 calories per gram, humans can only consume about somewhere less than 8 to 1,200 calories at a single meal. That's not even enough to get you through a single day, and as a result, we have to eat multiple meals during the day. Because of the small capacity of the human stomach and our inability to carrion, humans cannot recover large amounts of energy from a single carcass the way carnivores can. This is why hunting is much less beneficial for us. So in the absence of reliable, large-scale preservation methods, hunting is not an efficient way of obtaining energy for humans. This is why throughout history, crop failures have resulted in famine, starvation, and death for human populations. And this is also why plant-eating creatures like locusts are considered a plague, whereas to a carnivore, they're just additional food. All right, looking at the human small intestine, is extremely long. It averages 25 to 35 feet. I think I failed to mention that in herbivores, the small intestine is more than 10 times body length. Average human body length is 2.5 to 3 feet, meaning that our small intestine has the typical proportions of an herbivore's 10 to 11 times our body length. So, what's interesting is that down here, food transits the entire length of your small intestine in less than 2 hours. It only stays in the stomach about 3 to 4 hours, depending on what you eat. And that's going to become important in a minute. When you look at the mucosa of the small intestine, it's actually further, surface area is increased because it's compressed like an accordion, and then the surface area is thrown up into these little, oops, I went a little too fast. Come on, go back for me. Well, it's thrown up in these finger-like projections called villi and microvilli, and the bottom line is that the entire surface area in your small intestine is equal to the size of a singles tennis court. When you look at the human colon, we actually have a very long colon. It has a pouch structure. It has an appendix, which is interesting because only herbivores have an appendix. Its primary function: water absorption, fiber fermentation, producing short-chain fatty acids, and vitamin production and elimination. The human colon is a major organ of digestion. Food spends more time in your colon than it does in the stomach and small intestine combined. So when you eat a meal, it usually takes a minimum of 12 to 24 hours before you see that meal again. With vegans, it may average about 18 hours or so. If it only spends 3 to 4 hours in the stomach and 2 hours in the small intestine, that means most of the time is in your large intestine. And that's important because fermentation of fiber in the large intestine generates things called short-chain fatty acids that are important to our normal physiology. One short-chain fatty acid, butyrate, is important for keeping the cells in the colon healthy, which can prevent them from allowing you to absorb things that can cause autoimmune diseases. Another, called propionate, is taken up to the liver and can keep your blood sugar normal and keep your cholesterol low. And another one, acetate, can actually go to your muscles and allow the muscles to burn acetate instead of glucose, meaning that you don't get hungry as quickly. So it reduces food intake. Low fiber diets predispose us to a number of serious health problems and diseases. When no fiber is present, protein residues lead to putrefaction and toxin release and absorption, and can exacerbate conditions like ADHD and so forth. But with fiber, the bacteria are able to use the fiber residues instead of the protein for their energy substrate, and as a result, they don't end up causing the problems. So our digestive system is designed to quickly and efficiently extract most or all of the readily absorbable nutrients from digested foods, then allow an extended period of time for fermentation of the remaining fiber that ought to be there. It's kind of a biologic distillation process. I'm going to go through these last couple slides and then call it quits. And what we're now going to look at is a story of environmental impact. And what this first panel says, the aliens came from a far distant world in a large yellow ship that blinked as it twirled. It rounded the moon and entered our sky. We knew they'd come, but we didn't know why. Bright the next morning, with noisy commotion, the ship slowly moved out over the ocean. It lowered a tube and drained the whole sea for transport back home to their galaxy. The tube then sucked up the clouds in the air, causing no small amount of earthling despair. And with nothing to breathe, we started to die. Help us, please stop, was the public outcry. A hatch opened up, and the alien said, we're sorry to learn you soon will be dead. But though you may find this slightly macabre, we prefer your extinction to the loss of our job. And that's from a Calvin and Hobbes cartoon. Hobbes says to Calvin, Calvin says, that's my science fiction story. You think it's too far-fetched? Hobbes says, not enough, really. The thought of an alien species causing our extinction fills us with dread, yet again and again we've caused large-scale environmental destruction and the extinction of many of the Earth's other creatures by the ways we choose to eat and live. Modern hunting technology and human-caused environmental destruction is the chief reason for the extinction and endangerment of many of the other species on this planet. Every ecosystem, with the exception of Arctic regions, can support many more herbivores than carnivores because there's so much more plant energy available. As a result, herbivores always far outnumber carnivores due to energy conversion ratios. Because they are at the top of the food chain, carnivores are always the fewest in number of all the species in any ecosystem. At over 6.5 billion individuals, humans display the population dynamics of a social herbivore species. No carnivore or by design omnivore species has ever existed or could ever exist in such huge numbers. The Earth simply can't support it. It takes 10 to 13 pounds of feed to put 1 pound on a cow. This means that it takes far more energy, land, and water to raise meat for human consumption than it would if we ate the plants directly. 70% of the corn that's grown in this country every year is used to feed animals so that humans can turn around and eat them. To raise meat for consumption, it takes 17 times more 17 times more land, 14 times more water, and 10 times more energy. Cattle emit huge amounts of methane that has a warming effect 23 times as great as carbon dioxide, and they also emit nitrous oxide that has a warming effect 296 times as great as carbon dioxide. What that means is that overall, a T-bone steak is the equivalent of a Hummer on a plate. So if you switch to vegetarianism, that will reduce your carbon footprint by at least 1.5 tons of carbon a year. That's more than if you switch to a hybrid car. And trust me, the Earth will thank you. Now, lastly, we're just going to look more closely at the human environmental impact. And books such as Beyond Beef and The Empty Ocean and Water Follies document the destructive impact our animal food addiction has on our planet. In Beyond Beef, Jeremy Rifkin highlights the problems associated with beef production, including the famine, waste, and environmental destruction resulting from overgrazing cattle and raising rainforests to raise beef for export. Since 1970, more than 25% of Central American rainforests have been cleared for cattle pasture. He also discusses the toxic effects of billions of tons of animal waste. In this country alone, more than 11,000 tons of animal manure are produced per second. The misuse of water resources, over 50% of annual U.S. water usage is for raising livestock, and the massive amounts of fossil fuels used to grow grain to feed to animals. Fossil fuel-based farming uses non-renewable, non-recyclable forms of carbon and contributes to global warming. While Rifkin's book only deals with beef, the issues discussed are also germane to chicken and pork production as well. Back east, runoff from hog farms have caused massive fish kills in the river due to a bacteria called Listeria and other kinds of problems. In Water Follies, Robert Glennon explores the negative impact our overuse of groundwater for irrigation and agribusiness has on the environment, including ground salinization, and how our misuse portends a crisis of widespread water scarcity once we run out of it. In The Empty Ocean documents how human predation has caused the collapse of major fish stocks and threatens others. Many species have declined by more than 90%. A 2006 ocean census study predicts that by the year 2010, all commercially fished species will collapse. Author Richard Ellis further argues that human activities are driving many marine species like this sea turtle towards extinction because they are killed and discarded as unwanted bycatch. We are also destroying the architecture of the ocean by scouring reefs through reckless, indiscriminate bottom trawling for shrimp and other bottom-dwelling creatures. So these are 3 books that I would really urge you to think about getting because they're very good. So lastly, let me ask you, let's see. Oh, yes. At some point in the future, if there is one, when magnificent species like bluefin tuna and swordfish are no more, children will ask us what became of these ancient, ineffable, and irreplaceable creatures. What will we say? That we destroyed them for something as ephemeral, crass, prosaic, perverse, and unimportant as the way they tasted? What a sad, tragic, telling, and wanton legacy that would be. Now, I have to stop here. I have a couple more slides, but I've run 5 minutes over a minute and 15. So let me say that I thank you very much for your time and attention.